Welcome back, everyone. Everyone, please take your seats again. If everyone could take their last cup of coffee for now, and please rejoin us in Fontainebleau. Thank you. We have a fantastic panel lined up on securing the nuclear fuel supply chain, and the moderator is Jackie Sebens, who has recently joined Helion, but also has an affiliation with the Atlantic Council as a non-resident senior fellow with the Global Energy Center. So, Jackie, I'm so delighted to turn it over to you to introduce your panelists and moderate the panel. Thank you.
Thank you, Jennifer. I'm very excited to be here on this particular topic because this is really, and I'm going to probably have a lot of puns in here because I feel like it's impossible not to when you talk about nuclear at an event like this. But fuel really is at the core of so many of the challenges we're facing, both domestically and globally. But before we get started, I just want to briefly introduce our panelists. I probably don't need to give long-winded introductions. I think most of you know our esteemed panelists. But just to start off, we have Monica Regabuto from Idaho National Lab. We also have the Honorable Dan Poneman, CEO of Centrus. We have Seth Grae, head of Lightbridge. And we also have Joe Miller with BWXT. So a wonderful group of folks here to talk about this issue today. I am going to give a very short sort of overview, less than a minute, just to kick us off for this discussion. As we've heard from some of the other panelists today, we've seen a ton of momentum over the past 10 years building towards the deployment of advanced reactors. We've also seen growing support, especially here in the US, for keeping our existing nuclear power plants online. And as I mentioned before, fuel is absolutely central to achieving success in keeping our existing plants online and, of course, building out new nuclear. We often highlight the century-long commitment that comes with exporting a reactor. Yet, let's not forget the true heart of this relationship. Without the fuel, a reactor is merely an intricate sculpture of cement and steel and metal. And to truly dominate the global nuclear marketplace, we really have to focus on how we're going to build out access to both existing LEU as well as HALEU moving forward. So with that, I'll turn it over to my panelists. Dan, I would like to start with you. Russia currently holds nearly half of the global uranium enrichment capacity as per the World Nuclear Association. How does this position impact America's energy security, and what strategies should we consider in response?
First of all, I want to thank you, Jackie, and Jennifer, and Fred, and Landon for the Atlantic Council hosting this great event. In 1913, Winston Churchill was talking about oil. I hadn't planned this answer, but your question prompted it. He said, security comes from variety and variety alone. He meant diversity. That is no less true in 2023 than it was in 1913. And the fact of the matter is, when the United States, through a variety of mishaps and missteps, fell out of this market, concentration grew to the point where, as you said, WNA, impeccable data, has nearly half of the world's productive capacity. And the rest, there's only four significant enrichers in the world. And they're all state-owned enterprises: Russia, China, France, and Urenco. No disrespect intended to anyone. That is not how you make a robust, diverse, resilient supply chain. That's not how you assure price competition. So what is needed is more investment in new capacity, which is a theme we've heard many times today. There's a lot of talk because of the Ukraine war about sanctions and so forth. And sanctions do have a role when it comes to addressing international crises and so forth. But when it comes to creating new capacity, what we need is new investment, and that new investment is driven by demand, and it's got to be supported both by governments and by the private sector. The last thing I'll say is the following. As I said, every plant in the history of the world, including the US, has been bought and paid for by governments, right? Government investment is important. As was said in many of our panels before, there are many aspects of nuclear that are not addressed adequately by markets. It provides you resilience. It saved people's lives in the polar vortex in Minnesota in 2014. These are not rewarded by the marketplace. The LCOE debate we've had before, it's not a right way to measure. So when you measure those things that nuclear provides, it is fitting and proper that governments should play a role, but now with the great promise of the economic benefits to come along with it, private sector investment, I think, plays an also equally important role.
Thank you, Dan. And as we can all agree, creating a strong domestic supply chain for both LEU and HALEU is very important. But what key steps should we prioritize at this moment? We've certainly seen legislation passed that's supportive of building out a HALEU supply chain here in the United States of America, as well as making sure we have LEU domestically produced as well. But at this moment, what we've seen accomplished thus far, knowing there still needs to be more done in both the federal government support and private sector, I want to hear about what role some of the companies represented are playing here on stage. So I want to start with Joe, BWXT. We'd love to learn more about what you all are doing in this space, and then Seth about Lightbridge, Dan, Centris, and then we'll kick it over to hear about our national labs from Monica. Thank you.
Yeah, so a great question. When you talk about demand, the demand has to be there. So you have to prove the technology. We just heard one of the last panelists talk about that proof of concept is so important, and that's what we're doing in our company. So the proof of concept through Project Pele, proof of concept on an extreme temperature fuel in Project Draco starts to kickstart that industry. So that you start thinking about, what does the supply chain need? How do you ramp up production into hundreds and thousands and eventually metric tons, hundreds and thousands of metric tons of TRISO or other types of fuel that are required for these plants? So what we've seen over the last couple of years, our initial investment was lead with fuel. So determine the right type of fuel for the right type of application, with Project Pele being the first high temperature gas reactor that's being built, and it's being built today. And being able to deploy that and prove that technology is that Kickstarter that you need to get demand where it should be very soon. And so then, based on what Dan said and based on what we're seeing in the industry, you need to have a bridge in that gap. So as enrichment starts to increase and we start to have that domestic supply of HALEU, there's going to be a gap between now and then. At least I hope so, right? With all the projects that we have underway. So being able to take some of the existing stockpile, make it ready for HALEU production, make it ready for commercial is an important part of that step. And having that variety or having that diversity is going to come in multiple different ways. Since we do have uranium that's available, making that available when the demand is there, and then also standing up a big enrichment capability in the U.S. is going to be crucial for that.
Thank you so much. Seth.
Jackie, so not Winston Churchill, but John Kerry in this room this morning said that American parents won't send their kids off to war because of the energy transition, because we won't rely on our adversaries for our energy. So we're relying on Russia for almost half of our enrichment capacity. And so I think, weaning off that is an urgent national security matter. And as everyone is saying, this is going to come down to demand for the government and then the private sector to come in and support that. And at Lightbridge, we're developing advanced nuclear fuel that will work in the existing reactors as well as in the new water-cooled small modular reactors that will bring improved economics and safety and proliferation resistance. We're working closely with utilities, with SMR vendors to make sure that what we're designing is something that they would want to use in the end. We're working closely with Idaho National Laboratory to demonstrate production of the fuel samples and test them in research reactors. And by bringing nearer term demand to existing reactors for uranium enrichment as well as for new reactors, large and small, we think will help drive everything that will then follow, including with advanced reactors.
That's great. Thanks, Seth. Dan?
Well, next month, Centris will inaugurate the first new U.S.-owned, U.S. technology enrichment plant to begin production since 1954. Pause for effect. This was enabled by a cost-share grant with the Department of Energy, followed by a competed grant to operate this facility. One swallow does not make a summer. This will be 1 metric ton, a little shy of 1 metric ton per year. But what are we doing? We are trying to solve the chicken and egg conundrum. Nobody wants to build a fuel facility and invest in that without 10 reactor orders. You heard it here today. And nobody wants to order 10 reactors without a fuel supply. So how do we bridge the gap? That's why God invented public-private partnerships, right? So it has been announced. We're working with some of the OEMs already. And this is not rocket science, and it's not even unscalable at the level we're talking about, we could build within 42 months of a decision to proceed a new cascade of 120 machines that would add 6 metric tons of HALEU per year. And after that first cascade, we can add a new cascade every 6 months. So within 48 months of today, if we had a decision today, we're producing 13 metric tons of HALEU per year, which would be meaningful to, I think, people who care about these issues. If you wanted to produce LEU to fill the gap in the supply chain that we're witnessing because of Ukraine, that's a bigger story, more machines, more CapEx, but it's doable. But we take things in steps, and I see the opportunity we have even between now and the end of the year to make meaningful progress that I would hope by COP28 could let people say, you know what, we've solved the chicken and egg problem.
Thanks, Dan. That's very exciting. And, you know, Joe, you mentioned as well that even with progress moving forward on sort of the project Dan mentioned and Seth and yourself on building up these capabilities, there's still definitely a gap that we're going to experience. And, you know, I think many of us know that Idaho National Laboratory is playing a very important role in helping us navigate that gap. So we have material available to deploy some of these earlier reactors. So Monica, can you talk to us a little bit about what INL is currently doing in this space and how they're supporting navigating this gap that we're hearing about?
Yes, thank you, Jack, and thank you for having us here. First of all, congratulations to Dan, my long esteemed colleague for many years. And I don't know if you guys appreciate what it is to have the first NRC licensed HALEU production facility in this country. And so that is a big achievement. We all know and believe that long term, obviously enrichment is the solution for advanced reactors. But in an ideal world, we would have moved from an LEU economy to a high-assay LEU economy. Unfortunately, the world is not ideal, at least in the United States. And so that requires there's a little out of sync that we are doing while the enrichment capability is up and running. So with that comes supplemental HALEU stocks. And that is the role of our laboratory, Idaho National Laboratory. We are actually providing small quantities, which Lightbridge has beneficiary. And we're very happy to provide that service. That is for field qualification studies. Those tend to be virgin stocks that we give to folks who need them to do rodlets or whatever testing specimens. And they traditionally go to a test reactor, many times at ATR at INL, sometimes in another test reactor. But we're also doing bigger quantities, and that is we recover HEU from spent fuel. In our case, experimental breeder reactor 2, which was a fast reactor that was operated at the site. It was an HEU reactor, so we harvest the residual HEU, and then we downblend that up to HALEU, which is 20%. That material is in metal form and is more suited for non-contact handle fabrication. So for example, Oklo has requested 5 metric tons of that material. We have another 5 metric tons because it's a total of 10, and we're in the process of establishing a polishing line, which allows us to clean it up a little bit more so it can be used for a thermal spectrum, and that material will be available as oxide. So we're trying to bridge the gaps. We're not the only ones in the complex doing that. Actually, BWST and Y12 starting a scrap recovery effort, about 2.4 metric tons, if I get the numbers right. Savannah River also has about 2 metric tons that they are doing once appropriating funds come into place. And there are other couple of stocks of materials that NNSA has made available. We're always looking for the art of the possible. And I think going back to this morning's conversation where it's not like everything ends at 2030, right? It was one of the panelists who said that. You continue to provide materials to put into the pool as we're building this pool up. So the supplemental stocks are very critical to bridge that gap. And we're very happy to be able to assist industry at INL.
That's great. Thank you for that. And I just want to pick up on the topic of sort of the supplemental stocks. It was great hearing your viewpoint from the national labs and how that's vital to sort of providing this material through the gap we're experiencing. I'm curious to pick up on something you mentioned, Joe, and your experience at BWXT and how important sort of the existing material is that you've been able to access in the work that you all are doing?
Yeah, I think it's extremely important because it gives some immediate supply, right? Without an immediate supply, then we'll be vapor locked as an industry. So everything that Monica talked about is absolutely crucial to get that immediate supply out there, to go through these proof of concepts, to go through the early demonstration programs for the DOE and for the Department of Defense. So I think that has allowed more investment to come in, even from internal to companies, right? When we spend internal research and development dollars, those dollars are really hard to fight for, as is capital, right? And you have to look at return on capital. So because this fuel is available, because we have this immediate supply that can bridge the gap before the HALEU enrichment process is fully up and operating, has allowed our companies, BWXT, to invest millions of dollars in infrastructure to be able to put these prototypes out in the field, operate them, prove the technology, and then create another demand signal. The thing that surprised me the most was that demand signal came in a pretty big wave from commercial immediately after we announced Project Pele and after we won that contract. So we made another announcement midweek last week about our project in Wyoming. So you hear these industrial companies, mining companies, that are more worried now about energy security than energy prices, or at least equally as worried, right? And so that demand is starting to ramp really quickly, so we can parlay the efforts that the government has invested in for Department of Defense missions directly into commercial missions. And so that, to me, is the perfect relationship. And it's only allowed because we need to be able to field these reactors this decade. And so in order to do that, you have to have this urgent and immediate supply.
Just want to mention another word on the immense importance of Idaho National Laboratory. In the years following Fukushima, Norway closed down the Halden research reactor. Canada closed the National Research Universal Reactor at Chalk River. Russia invaded Ukraine in 2014 and 2022, cutting off access to the Mir reactor in Russia. U.S.-China relations prevented TerraPower and others from going ahead with research reactor use in China. When the advanced test reactor and the transient test reactor facility became available as user facilities to U.S. industry, they were literally the only facilities we could use in the world for this kind of testing and qualifying of new fuel. When we receive high-assay low-enriched uranium through INL, it's literally the only source in the world for it. So the immense importance of what INL has done on allowing U.S. industry to go forward, not just with HALEU supply, but the facilities, the expertise, is truly unique in the world in what is available to us.
You pick up on a really important point with how important and central Idaho National Laboratory and our lab system has been to U.S. development, but not just U.S., but certainly around the world with our allies and our partners. And on that topic, considering global partnerships, should we as a country, should the U.S. collaborate with ally nations more in broadening fuel cycle capabilities? And what can that look like? I'm going to open that up to the whole panel because I think you all have great perspectives on this.
So let me give you a little perspective on that. And the short answer is yes, we need to cooperate and collaborate with others. And I think Kirsten touched on that point in the previous panel. But people talk about HALEU, right? But HALEU requires uranium, and there are 3 steps before HALEU, right? So you have to go mining and conversion and then enrichment. The only country that can do all the steps before that is Russia and China coming. No other country has the capability to go from mining all the way to enrichment in the capacity that we need today. So that gives you a thought process of where are these pieces? We used to do that before the 80s, but we don't do it today. So do we need to cooperate? Yes. Energy security is national security. I think everybody in this room knows that. In the long run, we really should have all the way from the beginning, all the way from mining, because there is no reason why we couldn't. But it's going to take time, and that's why these cooperations are important.
I'm going to pick up from there. I'm going to say yes, but, right? Because we can, we should, we have had cooperation. About 7 years ago, I was talking to some of my non-proliferation friends. I come out of the non-proliferation world. And I said, because I'm consistent, I've been saying the same thing since I was a summer intern for John Glenn in 1975. The Nuclear Fuel Assurance Act, Steve Green remembers maybe. I said, we should be enriching uranium again. And they said, Dan, you're a non-proliferation expert. you know that U.S. policy is enrichment is bad, and that you should rely on the commercial market. If we're telling that to everybody else, why isn't that a good answer for us? I said, because we're the United States, and we need our own supply. And by the way, we need our supply for national security purposes too. So go back to Winston Churchill or John Kerry, but you need diversity. So what cooperation is fine, but not if you use it to become complacent and become so dependent on too few suppliers that you do not have resilience and multiplicity of sources of supply, because that's the beginning of the end.
Yeah. Well, I'll go back to what Dan Poneman just said and say that yes, and, which is that the United States has to have U.S.-controlled domestic enrichment for national security needs, so that no one else can have a policy that can cut off enrichment for the nuclear submarine and aircraft carrier propulsion that BWXT works on, for essential government research reactors and even the weapons program. That said, this has to be international, because for commercial use, working with our allies to expand existing enrichment plants will be quicker and cheaper than establishing from scratch. And the US enrichment will only get business if the customers know there's also a diversity of supply and competition and different suppliers in different places that can't be cut off, or if one is cut off, there's still supply. And these customers, as we deploy SMRs, microreactors, advanced reactors, will increasingly be international. And they'll be interested, well, what if the United States ever cuts us off too? So, we're going to need this for a robust global industry.
Yeah. May I drop a footnote there?
Sure.
Because Seth reminds me, way back in 2004, after the second Gulf War, then Professor Moniz and the late Arnold Cantor and John Deutsch and I wrote an article that proposed an assured nuclear fuel security initiative. And it said, nowadays, we want anybody who wants nuclear power to get it for climate change reasons. But just the sheer economics don't justify building a massive infrastructure for enrichment unless you have at least 20, 25 reactors. Very few countries meet that test, and it's a non-proliferation threat when you have too much enrichment floating around the world. So we propose exactly what Seth is talking about, which is assurance through a U.S. initiative that would be collaborative, that would be international, that other partners could come in both for offtake and equity investments, that would be backstopped at national levels and by the IAEA, precisely to avoid the single point of failure. I still think that's a good idea, and I think its time may have come.
No, I totally agree with you, Dan. And we've heard proliferation concerns come up a couple of different times in this conversation, so I'm going to take this opportunity to turn in that direction for just a minute. And again, this one is open to everyone. You all have great perspectives on this. How can fuel cycle strategies, including proliferation resistance by design, be used to mitigate some of the concerns that we see when it comes to sort of the growing demand and interest in new nuclear and some of these advanced reactor technology designs sort of spreading through the world?
Well, I can start if you like.
Please.
So we believe in deploying nuclear energy systems with confidence. And with confidence means addressing proliferation risk. Proliferation risk is real, and it needs to be addressed. We have a fantastic system for the current fleet, which is the commercial reactor fleet, the light water reactors. And IAEA has all the tools necessary to maintain that. Some of the new advanced reactors are similar as LWR, so they are a subset of that. But some are new. And for those new ones, we need to develop the toolkit. And that toolkit can be developed not by just copying and pasting what was done in the 70s, but actually by embracing the new technologies and the intrinsic attributes that are unique to that reactor design. What do I mean by advanced technologies? Not just material accounting, counting pencils, as I say. Some of these are bulk reactors where counting pencils is not the best mechanism. So you need to augment that, and the new technologies are here. We're doing test beds at Idaho National Laboratory, where we do AI, machine learning, digital twinning, in order to augment that toolkit. So the answer is yes, we can, we should, and we need to augment that toolkit, not just say, well, it doesn't work like an LWR, therefore it cannot be done. That is not the answer. The answer is, what are we going to do to deploy with confidence this reactor as we export?
Yeah. And can I just add on that? The we in that sentence is very important. You were asking a moment ago about the role of international collaboration. That's where it is. A chain, and especially a non-proliferation chain, is only as strong as its weakest link. Did I mention AQ Khan? Okay? And therefore, it's critically important. Just as with safety, it's all by peer review, and with this new WINS organization for nuclear security, peer review is important. The United States, I'm not casting aspersions on anyone else's standards, but the US non-proliferation laws are second to none. And every time we're out there in the international market exporting, we have a little flag that has all of those so-called Section 123 Act protections, and we promote the additional protocol. So that's why we should be, the United States, with all of our allies in Europe and around the world, taking that toolkit and making sure that we all apply it. Because we were in a situation in the 1970s when Germany was going to sell reprocessing and enrichment to Brazil, and France was going to send it to Pakistan, and that all gave rise to the so-called London Club, which became the Nuclear Suppliers Group, which was a good thing and promoted universal standards for export control, which have strengthened the overall non-proliferation regime. And in that sense, a strong civil sector, which depends on not having a bad problem emerge on proliferation, is a strong reinforcement to a powerful non-proliferation regime.
Sama Bilbaoui Leon and others today have talked about the tripling of nuclear power in the world by 2050, which would be about 800 gigawatts electric additional on top of what exists in the world 27 years from now. That would be about 800 large reactors worth of new nuclear generation, or thousands of microreactors and small modular reactors in probably over 100 countries, many remote locations, without non-proliferation by design. That will be almost impossible to have appropriate safeguards. So, a priority, I know, among many of the advanced reactor developers, certainly at Lightbridge as an advanced fuel developer, is building in non-proliferation by design. So yeah, it's great to have speed limits, but having crumple zones and anti-lock brakes are good too, and that's part of what we're doing.
Yeah, and you see that communication too right now, and the foresight by Idaho National Lab and the US government. A lot of conversation comes through our shop because we work on both national security, commercial, and civil applications with space. That was the reason why the space reactor is high-assay LEU instead of HEU. Mass is king in space, but we had to give up a little bit because the civil application, right? We wanted to use NASA like we always do in a very good socio-political ways with other countries and partnerships. We start using highly enriched uranium, that creates a big non-pro problem. So when you think about that up front before a program begins, it allows the developers, it allows the designers, it allows the reactor manufacturing companies to instill all of those programmatic effects into the design, into the program, and it keeps the communication constant, which has been very helpful for us over the last several years.
Do you think, and Dan, I guess I'll go to you first on this question, but when we talk about, as you talked about, you sort of come from the non-pro world, do you think there's still concern and pushback on pursuing domestic high-assay low-enriched uranium, or sort of a global deployment of that fuel, or no, we've sort of seen that start to fade?
There have been people who asserted it. I may have missed it, but I don't notice that it has gained traction, and I think that's because it doesn't make sense, in the sense that enriched uranium is enriched uranium. It's in a form, especially a form like TRISO fuel, it is not easily accessible again. You want to get it back to uranium hexafluoride gas if you want to re-enrich it to a higher assay. So to have a HALEU fuel that's enriched at 19.75%, which is below the legal limit, as Joe mentions, of HEU, it's, in terms of safeguards terms, it's the same kind of situation as you have with LEU. It's no greater risk, and in fact, and Monica would know far better than I, and probably everyone else does, the intrinsic aspects of like life of core loading and so forth, some of the intrinsic aspects of the HALEU fuel are more proliferation resistant than even a conventional fuel. But I don't mean to suggest that one's safer than the other. They're both safe. And I haven't seen a lot of traction, and I hope I don't.
Monica, can you comment on that? Because I am curious to just unpack a little bit the proliferation by design, non-proliferation by design piece of this and what that looks like practically. Because it sounds like high-assay low enriched uranium sort of lends itself to help with that very aspiration.
Yeah, so when we talk about that, you really have to put it in context, right? And what we really are looking at is what I call a sustainable energy system. Sustainable energy system has 3 dimensions, and it operates at the intersection of those 3. Economics, which is what everybody in this room knows, right? But there is the social part, which is proliferation risk, and there is the environmental part, which is the waste. And that at that intersection is where you obtain a sustainable system. That intersection is a little bit bigger for high-assay LEU fuels because the residual value of a spent fuel for high-assay LEU, it's more economic or potentially more economic to recover and being repurposed and reused in terms of sustainability. That intersection right now is very, very small for light water reactors, at least in this country. I know some European countries do that. And that intersection is small, but that is where we use technologies. So technologies can be used today to expand that intersection so we could achieve the sustainability that we need. We're not quite there for LWR, but that are the roles of the national laboratories and others in the world who are developing technologies to expand this intersection of the 3 dimensions. But you can't do one at the expense of the other, right? So one example, for example, at Idaho National Laboratory is Sursex. And Sursex is a front-end dry head-end process where we remove the cladding of spent fuel before we're gonna do the dissolution. So what we do is we actually downblend in situ HEU. So these are HEU fuels. We downblend them while we are removing the cladding to HALEU before we even separate. So you see, like, there is no HEU going into the separation process. In addition, because it is a dry head-end process, we reduce the amount of secondary waste compared to an aqueous process, like 400%, right? So that is the kind of innovation that we need. And I know ARPA-E is here, so there we go. And ARPA-E is heavily investing in also how do we expand that intersection for sustainable energy systems.
So I want to pick up on that now, especially now that you gave a shout out to ARPA-E.
Yeah, there's Bob.
Yes. So one of the things that we've seen, I think, getting more interest and attention, and surprisingly positive way, I would say, is sort of what does it potentially look like to have a closed nuclear fuel cycle in the United States? Now, a lot of people don't think of it this way, but we're already doing it at Idaho National Laboratory, as you described earlier. And there's interest from a lot of private sector companies in pursuing this, particularly for fast reactor technologies. In the conversation around proliferation, one of the largest concerns historically with closing the fuel cycle is the separation of material that could be used for weapons. So on this topic, I'm curious for each of the panelists' perspectives on should this be something that we consider as we move forward to trying to secure the fuel supply chain here in the United States. Please take it away.
So by going back to the sustainability, right, you have to be at that intersection for no matter what system it is, a fast reactor, LWR, whichever it is, right? Specifically for fast reactors, we have proven that with the EBR2 program and years ago, right? So it's not a matter of technology. What you really need to is you can't talk about separations without talking about reactor where you're going to put that separated material. Or it's not a separated material, but it's a recovered material. So if you don't have a path to put that recovered material immediately to beneficial uses, you shouldn't be reprocessing. Yeah. You have to do it in time to make your fuel and put it in a reactor. Otherwise, you stockpile, right? We don't do that. So you have to have a conversation that talks about recovery and reactor in the same sentence. Fuel fabrication being the key here, because many places don't have the ability to do fuel fabrication with recycled stocks. So if you are trying to put this in a place where they cannot handle recycled stocks and they cannot make fuel out of that, then again, the three pieces don't work together.
I think that's an excellent point, and you've just crystallized something that I've often had the question of, well, what's the difference between reprocessing and recycling? And you just
That's
nailed it.
You put it
I mean,
in
that's
beneficial
it.
uses.
Yes, you have to have sort of the rest of the cycle to keep it going, and I think that's really important.
If I may
So-
just say that's one
Yeah.
thing that's commonly misunderstood about U.S. policy, and I supported President Clinton on this in 1993, and people made exactly, Jackie, that mistake. The policy was not against reprocessing per se, it was against accumulating separated stocks. And that's why in the case of Japan at that time,
Yeah.
it was agreed that it was permissible for exactly the reason that they had a coherent plan, they had impeccable NPT and IEA credentials, they had a coherent energy strategy. So that's, Monica as usual nailed it.
Absolutely, and I think, you know, a theme that we are all so familiar with, as Dan brought up earlier, is this chicken and egg theme that keeps rearing its head. And I think this is also true when we think about potentially recycling fuel, right? We need to make sure, particularly in this instance, that we sort of know that the demand is there for this moving forward. We have about close to 5 minutes left, and I want to give each of our panelists an opportunity to talk about what they think in the next 2 years is the most critical action that needs to be taken by either the federal government, the private sector, or both together in partnership to make sure that by the end of this decade, we're in a better position to have domestic supply chain for nuclear fuel in this country to potentially, of course, supply across the world to folks that are interested in partnering with the U.S. So I'll start, Monica, with you. We'll go down the line.
So two things you said, right? Well, you have to keep the parallel approach. You have to release more potential candidates to be able to be put on the supplemental stock, because right now it's limited. And you need to make sure that the centrifuge program is fully funded so we can actually make progress. We can't start, go, because that actually costs more money, right? So we need to be able to complete that path and then complete with the supplemental stocks. The good news about HALO is it doesn't spoil with time. So if you have too much, you just store it, okay? So building that a quantity so the reactor developers are certain that there will be materials available for them for their demonstrations. That's where I think the next 2 years should be.
Great, thanks. Dan.
2 points. As usual, it wasn't planned, I'm going to follow exactly Monica's point. The first point is this. The real problem that causes this chicken and egg challenge is that however exciting the advanced reactor market is, there are no orders, there are no balance sheets, there are no Moody's ratings, okay? That's the problem. Guess who doesn't need any of that? The United States government. The United States government has an inexorable need. It may not be today, it may not be tomorrow, but this stuff like fish does not go bad in
Doesn't
3
go
days.
bad.
So, and this has been discussed, it's not a new idea. If the United States government said, you know what, we might not need that naval reactor fuel for a while, but we got a big catcher's mitt, and we will guarantee that that stuff will get bought. That completely de-risks the private investment, completely de-risks it. Because you know, even if, and we all want it to be flourishing, if it doesn't, the investors who aren't sentimental will not be left holding the bag. So the first thing is, like Rickover and Eisenhower taught us, like the EFI report that my colleague over there reported on earlier today says, there's an ecosystem between the nuclear navy and the commercial sector. It's vibrant, it's robust, we should leverage it. The second point is this, the fierce urgency of now. You heard Julie Kozaraki. If we wait another decade, it's going to be much more expensive. We've got to get this thing started now. Secretary Kerry, we're on the road to 2.4 degrees. We got to start now. And I would say COP28 is the day that we should all step up and say, we've solved, at least on the HALO thing, this chicken and egg problem. Let's get those reactors ordered. Let's get the fuel supply invested in, and we're going to rock and roll.
Love it. Seth and Joe, about 2 minutes each.
Okay, well, you started, Jackie, with talking about Russia having almost half the global uranium enrichment supply, and a fear among private investors who might otherwise invest in enrichment capacity is that after they invest over $1 billion and it takes years to build out the capacity, that things might have changed with Russia and that supply might be available here again. And so therefore what the Department of Energy needs to do is not just work with the private sector on creating firm demand in terms of dollars available to pay up front, but a guarantee that they will purchase at a certain price in a certain time period, so that even if Russian enrichment for some reason comes back online, or well, it's still online now, but in favor in the US and allied countries, that won't hurt the investors, that the DOE has a guaranteed price point and timing.
That's great. Thanks, Joe.
Yeah, I know exactly what I need to do. I need to deliver this reactor and turn the keys over to John Wagner. So that's 2 years away. And so that's going to kickstart the whole industry, because there will be an advanced reactor built with US technology, with US fuel, with US TRISO, on a US national lab site, just proving what the future is going to look like from a microreactor standpoint. In addition to that, all the milestones that the advanced reactor developers have in these big programs meet those milestones, because it will take multiple companies with a multiple mission pull to get that order book fulfilled that Dan talked about. So my job is to make sure that it's there and it works and it operates, and we'll all high five that success, right? But I think it will, over the next couple of years, like I mentioned earlier, that demand signal is getting stronger every single day. And so being able to translate that demand into programs that we can actionably deliver on is going to be crucial. That I see all that happening over the next couple of years.
Thanks so much, Joe. This has
Yeah.
all been fantastic. I just want to close by saying that, things in nuclear do take a long time. I think we all know that. And we've seen a marathon. We've all kind of been in this marathon towards sort of a resurgence in nuclear power, both here domestically and around the world. But at this moment, we find ourselves in a space where we need to sprint a little bit when it comes to making sure that we've got the nuclear supply chain for fuel that we need. And I think we've heard some wonderful ideas today from our panelists on what we need to do to get there. So thank you all very, very much. I am now going to ask Mr. Poneman to stay on stage because we have a special announcement. And I'm going to hand the mic over to Sama, if you would join us up here. And the rest of my panelists and myself can